right, so I've got 6 critters, and the list of those critters, it's not in any particular order other than alphabetical order. So don't think anything about the list. When you write them in your comp book, you're going to write them in order from the least related to the roly-poly to the most. So you do not need to write this part right here. This is just what you need to do. List the organisms from least to most related to the roly-poly. So there's 6 critters. Whichever one you write down first, that's the least related. Bam, 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 bam. Whichever one you write down last, you think is the most closely related to the roly-poly. Right? So these are our 6 critters. Trilobite, T. volcanium, sowbug, lobster, E. coli, caterpillar. So same thing. There might be critters on here that you've never heard of before or don't know what they are. That's fine. Do the best that you can. So this list is just in alphabetical order. Trilobite, T. volcanium, sowbug, lobster, E. coli, caterpillar. You are going to write it down in your comp book. The first one that you write is which of these 6 do you think is the least related, then which is still the least related. And then the last one that you write down, the last critter that you write down is the one you think is most closely related to a roly-poly. All right, so next, take the long, skinny sheet with all the critters on it. Then you're going to fold it in from the right and left, but don't cover up roly-poly, because that's the man of the hour. So fold it in from the right and the left to make doors on it so it fits in our comp book, but don't cover up roly-poly. All right, grab a highlighter. All right, so I'm doing it like this. I'm setting it up like this so I can see the outside and the inside at the same time. So you don't need to worry about having 2 of them. All right, these are levels of classification. Chances are by now you've already heard the different levels of classification. Do you remember any of them? Order of them? Domain, kingdom, phylum. Not yet, but almost. Class? Not yet. Order? Family, genus, species. Did you ever hear a little sentence that helps you tell them in order? Do you remember the sentence? Okay. All right. So because that's what I was doing in my head while we're going through that. Mine is daring. Daring King Philip. Dumb King Philip. Daring King Philip crossed oceans for grape soda. Yes. Wouldn't you? So Daring King Philip did. But that helps me remember in the order, and we'll look at that here in just a minute. So this first line right here represents domain. Roly-poly is in the domain Eukarya. So is the caterpillar. So is the lobster. So is the sowbug. So is the trilobite. So I'm going to highlight roly-poly again just so we're on the same page. E. coli and T. volcanium are not in the same domain. In fact, they're not even in the same domain as each other. But if I had pictures of these, can you imagine how I would take these 5, or these 4, wait, no, 1, 2, 3, 4, 5. If I take those 5 and put them in one group and put those 2 in another, does that make sense? Can you kind of visualize that? So that's probably what I would do. And then for these 2 in a group, then I could divide them down because they're in different domains themselves. The archaea domain, archaic things, they're usually prokaryotes that can stand really harsh environments. T. volcanium is thermoplasm volcanium. What harsh environment do you think that T. volcanium can withstand? And what's a characteristic of a volcano? So probably not, they wouldn't probably be able to survive like the lava because that's liquid rock, but I would think more than slightly warm. Very hot conditions they can survive. So that's archaic, harsh conditions, very hot, very cold. Lots of salinity, high salinity, pH, very acidic, very basic. So these critters are living in those environments that are very harsh and only a few critters can live in. And then E. coli, bacteria, we're used to E. coli. So because these are all in the domain Eukarya, they're more closely related to each other than they are to these guys. I would divide them out. All right, roly-poly is in the kingdom Animalia. So is the caterpillar, so is the lobster, so is the sow bug, so is the trilobite. So that really didn't help us. Darien King Philip, phylum. Roly-poly's phylum Arthropoda, so is the caterpillar, so is the lobster, so is the sow bug, so is the trilobite. Darien King Philip crossed. So the class of the roly-poly is Malacostraca. It's in the same class as lobster and the sow bug. The roly-poly shares more levels of classification with the lobster than it does the caterpillar. So it is more closely related to a lobster than it is to a caterpillar. The roly-poly is more closely related to a sow bug than it is to, the roly-poly is to a caterpillar. Does anybody know what trilobites are? Have you ever heard of that before? Ancient, extinct creature. Kind of looks like a roly-poly, kind of has the armadillo look to it. All right, roly-poly, Darien King Philip crossed oceans. The order for roly-poly is Isopoda. Sow bug is Isopoda. So roly-poly is much more closely related to sow bug than it is to the lobster. But it is more closely related to the lobster than to caterpillar. Any idea what's the rule that I'm using to say that they're more closely related to one than the other? Roly-poly is more closely related to the lobster than to caterpillar. So the number of levels of classification they share, the more levels of classification critters share, the more closely related they are. So roly-poly is more related to the sow bug, or more closely related to the sow bug than the lobster. Why is that? Share more characteristics. So Darien King Philip crossed oceans for a family is Armadillidae for roly-poly, which makes sense. Armadillo, roly-poly ball, looks like armadillo. But not for the sow bug. So it's more closely related to it, but it's not the same species, which is good because every single species has its own distinct genus and species name, its own distinct scientific name. All right, so take a look at your list, your hypothesis. Were the first ones that you wrote down, one or both of the first ones you wrote down, E. coli, T. volcanium, were they at the top of your list? Was sow bug at the bottom of your list? Most closely related, sow bug. So it probably should have been E. coli, T. volcanium. They would have been up there. Then caterpillar, trilobite for third and fourth place. Either one that could be swapped around. Then lobster, then sow bug. According to what we have, that's probably about what it should have been, based on our levels of classification. Okay. So, now put your pencils down for just a minute because I want you to listen for just a second. Now I'm on the right-hand side of my comp book. On the right-hand side of my comp book, I'm going to put my little insert, but I'm going to put my little insert so that it lines up. I've added humans to the mix. Humans are in the same domain as a roly-poly. Aw, I'm going to make you feel closer to them. We're in the same kingdom as a roly-poly. Aw, that's it. So, levels of classification-wise, once again, roly-poly is more closely related to a lobster than they are to us. And that kind of makes sense. Then, all the way, this is on the left-hand side of the margin, domain, kingdom, and I lined it up. So I skipped this spot right here because that's nothing. Eukarya, that's a domain, kingdom, phylum, class, and I'll tell you why I highlighted that in just a second. So I would suggest you lay it and write this stuff down first and then tape it, because if you tape it, you can't write on tape very well. So I would suggest you copy stuff down first and then tape it in. So humans, eukarya, animalia, chordata, mammalia, primate, hominidae, Homo sapiens. Hominidae is Hominidae. All right, so the sentence, Daring King Philip crossed oceans for grape soda, can help me remember domain, kingdom, phylum, class, order, family, genus, species, and those levels of classification from the most broad to the most specific. All right, pencils down for just a minute. I just want you to watch and listen to my melodious voice for just a second, and I'll give you a chance to copy this down. Phylogenetic tree, cladogram, the little NOVA activity kind of introduced you to it. The diagrams that you saw in the NOVA activity probably looked a little bit like this. We'll look at another one here in just a second. So this represents the beginning of whatever time that we're using for whatever group of critters that you're looking at. So you're looking at a certain group of critters. All right, so there was a time when they had to have divided off based on characteristics. On here it says eukaryote and prokaryote, and we didn't necessarily put that in our levels of classification because these are characteristics, whereas eukarya are eukaryotes. But do we know the difference between eukaryote and prokaryote? Have we heard them before at all? Okay. Do you know what it has to do with? It has to do with cells. Not having a nucleus versus having a nucleus. Do you know which one means that they do have a nucleus? You do. Eukaryotes do have a nucleus. Pro, no nucleus. And that's a simplification. But eukaryote do have a nucleus, prokaryote don't. So imagine, like I said, we took those little, if we had pictures of our critters, and I said I'd divide them, and I have these two over here and all of the rest of them over there. Well, the two that I put aside were T. volcanium and E. coli, and all the rest in another group. So that's how I would divide that out, and that's kind of showing it. I'd put these two over here and all the rest over there. T. volcanium and E. coli weren't even in the same domain, so I divide those out as well. And we'll talk about the colors and all the rest of that here in just a second. So that was archaea, that was bacteria. Then I can use these levels of classification to further classify the critters that I have. So humans were in here. They shared a couple of characteristics with roly-poly, but not very many. So it branches off relatively early. It's chordata, where all of the rest of them are not chordata, they are arthropoda. Of all the arthropoda, then we went ahead and we can divide those down. Malacostraca, that was these guys over here. Isopoda, and I can't even remember what the last ones were to actually divide roly-poly and sow-bug out. Trilobite, caterpillar, they're arthropoda, but then Trilobita and insecta, that divided those out. But when we were kind of looking at them, T. volcanium and E. coli, we said either one of them could have been at the top of the list as the least related. And so that's kind of where this little bracket comes in. They're sister taxa. So they're more closely related to each other than everything else on here. Roly-poly and sow-bug, they were the last ones that we went through. They're more closely related to each other than they are to anything else on here. Trilobite and caterpillar, those were could have been either 3 or 4. We could have flipped it either way. And so they're more closely related to each other than anything else on here. So basal taxon. So each one of those little branches showing basal taxon, and then outgroup. So they share some couple levels of classification, but not completely related. So I've taken and I've highlighted sister taxa, one color, my basal taxon, another color, and my outgroup, why am I having trouble with that? Outgroup, a third color. So in just a second, I'll have you do this first. You can choose whatever colors you want, but keep in mind that you need 3. And then I'll flip this over so that you can see the vocab underneath. All right, so basal taxon, they diverged early. My outgroup, still kind of within this group, but doesn't have a whole lot of things that they share. Sister taxa are going to share a lot of levels of classification. All right, so you need one of those little pieces of paper that you picked up. and then go ahead and copy that diagram onto that little slip of paper. So on the NOVA activity, it talked about common ancestors and how this would be a branching point to show the presence of a common ancestor that's common to these guys. And so this would show an area, a point, where there would be a common ancestor to all of those folks up there. All right, so green, yellow, orange. The yellow shows basal taxon, so it's a taxon that diverged early from the rest of the group. Diverged from the group early. Sister taxa was the green, the ones that are closer together. So of the group, these share an immediate common ancestor and are closely related to each other. They're going to have more levels of classification in common for our activity. So sister taxa of the group, these share an immediate common ancestor and are closely related to each other. And then the orange was the out group. Share a couple levels of classification, but not closely related. An out group shares a couple levels of classification, but not closely related. So chances are you've learned about writing a scientific name as well. So we'll just really briefly go into how to write a scientific name. Scientific names help all scientists be on the same board with what living critters that they're talking about. So we know exactly what we're talking about. Because roly-poly and sow-bug, they're closely related, and honestly, they're even more, they look very, very similar to each other. So both of them have the little armadillo kind of segments on their body. They've got the little antenna, a whole bunch of cute little feet. They're usually living in the same sort of environment. The difference is the sow-bug doesn't roll up into the little ball, and it's a little bit flatter, and it's a little bit faster. So they look similar to each other, but there are differences to them. But if you're running an experiment and you accidentally get sow-bugs instead of roly-poly because it's going to affect the experiment. So scientific names help to keep everybody on the same page. When you write a scientific name, there are basically two words, genus and species. Genus, the first letter of the genus is capitalized. Species, the first letter is lowercase. If the scientific name is typed, if it's in typewriting, then it's going to be typed in italics. If you are handwriting a scientific name, you need to underline it because you cannot type in italics. As scientists, we like to abbreviate as much as we can. And so we know it as E. coli, but especially if you look at the little foldable, you'll see it should be Escherichia coli. Well, we don't want to write out Escherichia coli every time, so E capitalized, and that's our abbreviation, coli, and that works just fine. We already talked about this. We figured out that the more levels of classification that organisms share, the more closely related they are. levels of classification that organisms share, the more closely related they are. And so if you actually go into ecology and anthropology and whatever, there is a difference between a phylogenetic tree and a cladogram. I don't think that it's necessarily important for us, and I think a lot of times even the ones that I draw are kind of like a mixture of the two. I'm guessing it might be important to see those terms, and I can't remember if that was on vocab number 9, but it won't hurt us to write them down again, even if we did. So there are differences, there are technical differences between them. I don't think you're ever going to see a question on the AP Bio Tester in my class that says, which one of these is a phylogenetic tree, which one of these is a cladogram. So phylogenetic tree, it may have longer/shorter lines to show time, inferred evolutionary change, and or shared characteristics/common ancestors. So the phylogenetic tree may have longer/shorter lines to show time, inferred evolutionary change, and or shared characteristics/common ancestors. Cladogram, the lines are usually equidistant, and the clade just shows relatedness. Lines are usually equidistant, and the clade just shows how critters are related to each other. So the little classification activity we did with the pictures, I mean, we didn't draw it so that it looked like this necessarily. It probably looked maybe a little bit more like this, and I'm not going to have you copy this down. I just want to show you that, you could see a diagram that looks like this instead. So just a diagonal line on here, T. volcanium, E. coli, those were basal taxon that diverged off early, but these are sister taxa right here, and we can still kind of see that. We can use characteristics to divide them out. Here's humans, that was our out group that shared some characteristics, but not a bunch. For these right here, roly-poly sow bug, sister taxon, trilobite, caterpillar, sister taxon on that one as well. So it might look a little bit different. Okay, so next I need you to grab this slip and I need you to number it top to bottom, just 1 through 7. We're just putting numbers on there just so that we have something that we can use to label them, like so as names, if you will. So 1 through 7. And notice when I copied your number 1, his little antenna got kind of cut off, so fix his antenna because that will be important. So we may not cut those out today. Eventually we'll cut those out. So I've flipped to a new page, and so we'll talk about this stuff probably tomorrow. But for right now on the bottom, I do want you to go ahead and copy down this data table. So here's 4 characteristics that we can observe in these critters. Eyes and antenna. The critters have both eyes and antenna. Y-shaped antenna, segmented body, legs. And then across the top, 1, 2, 3, 4, 5, 6, 7, that just represents essentially the names of those critters. And it doesn't have to be, perfect data table. We're just kind of getting some information on there, and we want to organize that information. All right, so when you look at those 7 little critters, how many of them have both eyes and antenna? all of them have eyes and antenna. So I just go through my little data table, check mark, X, whatever. They all have eyes and antenna. Do they all have Y-shaped antenna? Which one or ones do not? So number 5 does not have Y-shaped antenna, but all the rest of them do. So check mark X on all of them except 5. Do they all have body segments? Nope. Which one or ones do not have segmented bodies? 1, 5, 7 do not, but all the rest of them do. Do they all have legs? Which one or ones do not have legs? Does number 1 have legs? No. Does number 2 have legs? Yes. Does number 3 have legs? No. Does number 4 have legs? Does number 5 have legs? Does number 6? Number 7? Harder than you had to. Okay? So first things first, there are 2 critters that are very closely related to each other. Which 2 are relatively closely related to each other? We'll get to those in just a second. 1 and 7, they're sharing the same characteristics. They would be in a little sister taxa. All right, then what other ones are closely related to each other? 2, 6, and 2, 4, and 6, all sharing the same characteristics. The sister taxa is usually 2, so we would probably look at 2, 4, and 6, and we see that 2 and 4, they've got a couple characteristics that they share. 6, we can either divide 6 out because it's got like scales on its back, or 2 we could divide out, or no, actually, because it's still got segmented bodies, so we wouldn't necessarily do that. But we have an additional characteristic that might kick 6 out, and so 2 and 4 might be sister taxa to each other. All right, so just listening to my melodious voice for just a second. So in just a moment, I'll have you copy this down, but we're going to do a different diagram this way. We're going to do the other style. So notice how I've got eyes and antenna all the way down here. All of them have eyes and antenna. They all have that characteristic. They don't all have Y-shaped antenna. We kicked number 5 out. So before that characteristic developed, number 5 was existing, but then that characteristic developed and all the rest of these have Y-shaped antenna. Not all of them have segmented body. 1 and 7 have Y-shaped antenna, but they don't have a segmented body. 1 and 7 are different critters. They diverge up here because number 7 has the little squares on the ends of its antenna, whereas number 1 doesn't. That's a characteristic that I could use to divide them out. So these all have segmented bodies. Some have legs, some don't. Number 3 didn't have legs, and actually all of those didn't have legs, but number 3 is going to be divided out. It has a little squiggly tail, though, and so that's a characteristic for number 3. Number 6 has the scales on its back. Then 2 and 4, that might be sister taxa as well. What's separating 2 from 4 is 2 has 3 segments, whereas 4 only has 2 segments on its body. But they all have segmented. So the characteristics can be used in order to divide them out. Do you see where I placed everything at? All right, so that's your second little white sheet of paper. Go ahead and copy that down.